Hello again, welcome to this session. Now in this session again, in this slide I want all of you to see the overview where we can see the entire various aspects of the ISO 26262. In this particular session we are going to discuss product development at a software level, which I have highlighted as number 3. As you can see, when you expand the software level, these are all the various topics that needs to be touched upon, which need to be discussed about in this particular session. As you can see, the software comprises of the general topics of product development at software level, and let me tell you beforehand, all these things I will be expanding, elaborating in the coming slides. Specification of the software requirements, software safety requirements, software architectural design, software unit design and implementation, software unit verification, testing of the embedded software. All these various things will be clearly outlined. Now, also keep in mind that development of software is usually done by a systematic procedure called V model, and I assume everybody is aware of this V model. V model, as you can see on the right side, it comprises of the various steps. The left side of the V model comprises of the design and development, and the right side comprises of the verification and validation. So, discussion of this V model is beyond the scope of this particular seminar or particular session. But please remember that V model is an important step in the software development life cycle. Functional safety at the software level, let's see in a more elaborate manner. Now, talking about the various software in various ECs in the vehicle, software must contribute to the safety of the vehicle and must not endanger the safety of the passengers in the vehicle. This is the main requirement of the software. Now, as vehicle is becoming more and more software defined, as vehicle is becoming more and more software dependent, more and more software is present in the vehicle. As you all know, almost the amount of software present in a modern autonomous vehicle is more than the software which is present in a Boeing 747. So you can just have a rough estimate what is the magnitude of software that is present in a modern vehicle. Now, software must contribute to the safety of the vehicle and must not endanger the safety of the passengers in the vehicle. This means that the software must be error free. Software must be error free. I mean, in one of the previous videos you saw in the YouTube video that accelerator got stuck without actuating it, and that led to fatality of the 4 passengers. That happened because of some software error. So all of you must keep in mind the magnitude of the importance of software being error free. And software errors are always systematic errors, they are not random errors. That is the reason why software must be developed in a systematic manner. Of software development must be compatible to agile development, and instructions are outlined in ISO 26262 part 6. So you must understand that sometimes software development must be compatible with the agile development also, provided all the instructions and all the documentation are clearly outlined. Now, there is one more important requirement that must be met. Softwares must also meet the interface requirement with the hardware. Okay, I'm sure everybody knows that there is a proper software and hardware interface, which is, it may be an AutoSAR, or it may be an RTOS, or it may be a base software, or it may be an application software. So all these various kinds of softwares, they have their own independent interface with the hardware. Nowadays, interface is becoming more and more streamlined thanks to architecture like AutoSAR. And also, software must succeed in fault injection tests. So software, when you develop software, the software developer must keep in mind that a fault injection test is fulfilled. I mean, the software must pass, or it must fulfill all the requirements of fault injection tests. Error-free software is becoming increasingly important for vehicle safety. As I mentioned, the software is becoming of paramount importance, and error in the software can also lead to fatality of the vehicle. I mean, that is, you must understand that software being error-free is so important, so critical, and mechanisms for fault tolerance must be in place to combat the occurrence of faults. So whenever there is a fault or an error, the vehicle may go haywire, the vehicle operation may go haywire. Then to prevent the vehicle's operation from going haywire, mechanisms must be placed inside the vehicle, and the software process must be modified to comply with ISO 26262 requirements and content in order to ensure functional safety. It is also necessary to provide to specify all the functional safety technical standards, including quality software safety ones. So what are all the various software quality which must be aligned or which must fulfill the MISRA compliance, and all the functional requirements and safety measures must be implemented by the software architecture. I mean, you must understand that writing the code is one thing and having a proper software architecture is another thing. If writing a proper code without a proper software architecture, without knowing how one software unit interacts with other software unit, is sheer waste of efforts. So proper software architecture must be clearly outlined, and sorry, safety analysis must be performed to understand dependencies between the safety components and validate the software design. Understand this very carefully. Safety analysis must be performed to understand dependencies between the software components and validate the design. So let me explain this particular point little bit. Sometimes it so happens that some software components may be ASIL D and some software components may be ASIL A, depending upon the criticality of it. So it must happen that a ASIL A component should never put ASIL D component at risk, or vice versa. They must be independent even though they are interconnected. Okay, understand this sentence very carefully. Tests and software integration must be properly executed and described in terms of methodology. The use cases must be properly outlined, and the tests must cover all the use cases, so that the software integration must be properly executed and described in terms of methodology. And to determine the completeness of the test and bolster the argument that test objectives have been met, test coverage has to be quantified. So a test coverage, what are all the various use cases a particular test is covering, and the test must be such that a convincing argument can be placed that test objectives have been met, must be clearly quantified. Understand this sentence very carefully. A convincing argument that the test has been passed must be clearly put forth.